We are going to discuss about a project called solar based smart inverter with IoT. So in this project we are going to consider a solar panel, and this solar panel will generate a voltage of 6 volts. Okay, and it will be giving you that output to a particular uh, lead acid battery. So it is a rechargeable battery, so that whatever the output you are going to get here, that will be get connected to your respective battery, and it will be get charged here. And this is a 12 volts battery, okay, which will be charging up to 12 volts here, and it is a DC voltage. And here we have used a switch to turn on and turn off this particular system. And whenever the system gets turned on, all the systems gets activated here. And here we have used a small power supply circuit, okay, which will be used for converting that 12 volts of DC voltage to 5 volts. Okay, and since we are going to make use of a IC called 7805 voltage regulator, okay, and it is having 3 pins here: input, ground, and output. Okay, and whatever the devices we have used here, these all the devices will be working with the 5 volts. So that's why we have made use of this particular 7805 voltage regulator, which is regulated to 5 volts. Means we are stepping down the 12 volts to 5 volts here. And at the inverter end, we are going to have a inverter with the MOSFETs and the transformer and the coil, okay, which will be acting like an inductor, we can say. And this will be converting that 12 volts of DC voltage to 230 volts or 220 volts of AC voltage. And this AC voltage is given to a AC voltage sensor, okay, where you are going to get that output here. Okay, once the data is get captured by this particular information, okay, the 230 volts or to the 200 to 230 volts of AC voltage is fed to this particular AC voltage sensor, okay, which is based on the optocoupler here. And this optocoupler will be processed by this comparator, and it will be giving you the output here. And here there is a potentiometer which is used for changing the sensitivity of that particular device. Okay, and parallelly we have connected a bulb here to turn on and turn off that particular bulb, okay, controlling via IoT. So that is what the thing here. And whatever the pins we are going to have here, these are the AC input pins which are directly connected to here. And whatever the pins you are going to have here, there are 4 pins, okay, which includes VCC, 2 grounds, and output. And this output is fed to the analog pin of your particular microcontroller. So here we have used a microcontroller called Node MCU ESP8266 microcontroller module, okay, which is a 32-bit microcontroller with 30 pins inside of it. Okay, so 15 on the left and 15 on the right here. Okay, and it is having 16 GPIO pins, which is operated with a frequency of 80 megahertz. And the specialty of this device is that it is inbuilt having Wi-Fi module inside of it, which is operating with a frequency of 2.4 gigahertz. And it consumes only 3.3 volts to 5 volts of DC voltage. So that's why we have made use of it. And here what are the pins we have considered? The 3.3 volts and the ground is given to the relay module to turn on that particular relay. And what are the D4 pin is there, okay, which is nothing but the digital pin, which is a part of a GPIO pin. Okay, thus out of the 16 GPIO pin, the D4 pin is one of it. Okay, and why only D4? We can connect it to any of the D ports. Okay, so here you can see the D0 to D11. Okay, so out of this one you can connect to any of it. Okay, it's up to you. Okay, here we have considered only D4. Okay, we can go with the D1 or D2. Okay, but we have to change in the program. Okay, so this is the input signal which is given to the relay here. Okay, whenever we give a high command to this particular device, then a 5 volts will be given as an input to this particular relay, and it gets energizes and uses a principle called electromagnetic induction. Okay, and whatever the relay is there, it is a electromechanical switch or a magnetic switch which is used for switching the sources. Okay, here we have switched the sources of 230 volts of AC voltage which is coming out from this particular inverter. Parallelly we have given as an input to it. Okay, so this is the 230 volts of AC voltage here, and it is switching from here to here whenever I have given that on command. And this 230 volts of AC voltage is passing from here, turning on this light and making it to a neutral one. So that is what the thing here which we have considered. Got it? So this is all about your particular project.